Okay, so to find this particular solution, they're asking me to solve for y. So what original function would make this be true, where this is its derivative? So I did go ahead and change y prime into dy dx already. Now, again, each of these steps, each one of these questions, you need to separate the variables, you need to integrate, you always deal with c, and you always solve for y. Sometimes separating the variables can be harder, require more steps or more difficult algebra. Sometimes the integration is harder, especially if it's u substitution. Sometimes if you've got information to deal with c, to solve for c, then to me that's more work, so that makes it harder. And of course, solving for y can be just finished depending on the question versus still needing a few steps. But all that being said, for this one, it looks like the y stuff needs to go to the left, and then this is going to need to go to the right. But at some point, you need to be able to separate these. So just like question 6, eventually at some point, you need to factor out that x. You need to factor out a GCF. So to me, there's too many steps to do the separation in one step. So I multiplied the dx over, I factored out an x, I could divide both sides by x squared, and I could divide both sides by 5 minus 6y. And you want to be careful that you don't lose anything, because you don't want to spend another 5 minutes on this question and just giving yourself no shot. Now these two can cancel and make 1 over x at least. So, okay, I think we are completely separated now. Okay, we're still okay? Okay, then the whole point of separating is to make the integration work out. So on the right side, this is one that we just memorized, so that should take us about 3 seconds. On the left, unfortunately, this one looks like he's got some chain rule in there, and to be honest, I'm not 100% comfortable doing that without making a mistake. So worst case with integration is to do the u substitution. Think about what you have, what you need. I need this to be 3 dy, so multiplying by negative 1/2, so that you can rewrite the question. Now, of course, you don't have to do it that quickly, but u substitution, remember when we did that, and I told you that it's probably the single most important thing we do all year. If you feel like you're getting rusty at u substitution, you need to practice that some more. Okay, now it fits a pattern that I memorize. Can plug in my u. So that slows me down a bit, but at least I didn't have to do that on the right side also. Okay, are you still with me through the integration part? Okay. Then the next thing you always have to do is deal with c. So sometimes it's just a matter of remembering to put plus c if it's a general solution question. In this one, they gave us a point that our answer needs to go through. So when x is 2, y is 1, we need to plug that in and solve for c. Actually, this is looking familiar. This might be the one we did on our notes. The absolute value one. That's fine, we can finish it. I'm just...
Yeah, no, I didn't even like the separation of variables part at the beginning.
Oh, okay.
So,
Are,
yeah.
are you okay with how I did that though?
Yeah, now I am. Now that you
Okay.
walked through it, but
Are you okay with the u substitution?
yeah.
Okay. Let's just go ahead and finish it since we're so close anyway. Plug in 1 for y, this becomes negative 1, absolute value makes it positive 1, but the natural log of positive 1 would be 0, 0 times negative 1/2 would be 0, c is negative. It's just on that other handout, I like it did the first half of the question for us, so we could just focus on the absolute value part. You do all of that so that you can plug that in, and you have now successfully dealt with c. The last thing you need to do is now solve for y. And this one, everything about this question seems to be the hard version. It was a hard separation of variables. It was hard integration because u substitution. They gave us a point, so solving for c is more work than not having to solve for c. And then solving for y also looks like it's going to take a few steps. So I multiplied everything by -2. I exponentiated. Over here, e to the log base e of this stuff just becomes this stuff. I'm going to leave the absolute value sign there for just a second to make sure I have to keep up with that. Now on this, do you guys see, because I kind of flew through this on the other handout because it's not what I really want you to focus on. This, you need to understand, comes out to be x to the -2. Do you know why that needs to be x to the -2? Okay, if you don't, it's because it's almost this property that we have to use here. A number to the log of the same, but the base of the same number of something just simplifies to be that something. This is e to the log base e of some stuff, but you can't just ignore that this -2 is here. You can't just put a number here and it still be the same property. So 99% of the time with logarithms we bring this exponent down, but in this case we actually want to move it up out of the way. Now it's e to the log base e of some stuff, and so it just simplifies to that stuff. And then exact same thing over here. E to the log base e, if I move this up, that becomes 2 squared and just becomes 4.
Why did you just get rid of the addition?
I didn't, I changed it to multiplication. Because the way you're used to seeing it is this direction. When you multiply things with the same base, you add the exponents. This is the exponents being added, so I'm splitting it apart. I'm doing e to this, I'll write it out as an extra step. I'm doing e to this one times e to this one. So you're going this way. It's a little bit harder to see, but it does happen quite a bit on these questions. But then because of this property, all of this becomes x to the -2. All of this becomes 2 squared, which I'm just going to call 4. And then at some point, you want to remove these absolute value signs. And so this morning was the first time I told you how to deal with that. This stuff could equal the positive version of this, or it could equal the negative version of this. So for this to disappear, you should plug in that initial condition, 2, 1, and see if it should be, let's rewrite this, multiply those. See if it works or if it's the opposite of what you want. So if I plug in 1 for y, this side becomes -1. If I plug in 2 for x, this side becomes +1. That's a problem. So this time, the inside of this absolute value stuff did not equal the positive version, it equals the negative version. I need to make sure those stay equal. Subtract the 5, divide both sides by -6. Okay, well, there we go. Question was so long it crashed the program. See how much I lost. Okay. Divide both sides by -6. Reduce your fraction. And now you've got it down to y equals. Optional, but highly suggested, is make sure your final answer goes to this point. By the way, this is a good test taking strategy too. When you see a multiple choice question, and let's say it's one of these problems, and you get an answer or you're just not confident in your answer, you could probably eliminate some of the choices just by checking, if I plug this in, does it work? So if I plug in 2 here, I get 2/12, which is the same thing as 1/6. 1/6 plus 5/6 equals 1, And the fact that it does go through that point is a good sign for that. Doesn't guarantee it, but probably fine. Now, I will also add that this version, or this question, was pretty much worst case scenario for everything. Hard separation, the hardest integration, having to deal with C, actually solve for it, and one of the tougher solving for Y. Most real AP questions are just like a combination of that. They're not usually all the parts are hard. One question might be tough on separation and integration. Another question might be tough on solving for Y, but you usually don't have all four of the steps being difficult.